Hi, welcome to our talk. My name is Martin. I'm a software engineer at Facebook, working on Presto, and this is Camille from Teradata. So today I'm gonna do a quick introduction to Presto, like a brief description. Then we're gonna talk about how we use Presto at Facebook and at some other companies. And then we're gonna finish with an overview of recent new features we added, basically over the last year or so, and things that we're going to be building over the next few months. So, quick poll, how many people don't know what Presto is? Okay, there's quite a bit. All right. So Presto is a distributed query engine designed for low latency analytics over large data sets. It supports a subset of ANSI SQL 2011 with a few extensions that are not covered by the, or contemplated by the standard. And the gap is narrowing. We're building a bunch of new features, especially over the last few months, and over the next few months, we're going to be adding a bunch more things to narrow that gap. There's a bunch of things coming up from the people at Teradata. They're contributing large number of changes. And it's open source. It's available under the Apache license. All the code is on GitHub, and we do all development in the open. So you can actually go and see every pull request that flows through, all the discussions and code reviews. They're available for anyone to look at. One of the distinctive features, actually one of the most powerful features of Presto is that it's extensible. So you can write plugins and extend the functionality. A plugin can provide new functions, new data types, or a integration with external data storage engines. And we're going to talk a bit about that in a moment. So this is the high-level architecture of a Presto installation. There's a coordinator that takes SQL queries from clients. It parses the query, analyzes it, plans it, optimizes it, and then sets up the execution pipeline across the cluster of workers that are available. Then workers fetch data. As they process data, they fetch it from either upstream another upstream worker, or from an external data source. Then they take that data, they apply projections, aggregations, filters, or whatever operation dictated by the shape of the query you're running. And then they put the data in an in-memory buffer for the next worker in line to come and fetch it. And then at the end, the data is sent to the client. So it's a pretty simple, pretty straightforward MPP architecture, like nothing magic about it. And then plugins can provide implementations of metadata APIs that describe tables, columns, and types, and a way to fetch the data for those tables, and then Presto can interact with those external systems. So we originally designed Presto to address a problem that we had at Facebook, where we had people trying to run ad hoc interactive queries over the Hadoop warehouse, and there was no good alternative. They were relying on Hive, and basically they submit a query and they waited and waited and waited for half an hour to get an answer. So we implemented Presto to allow them to run queries over the same data sets, but at interactive speeds. And then over time, we expand the use beyond that to support other use cases and other applications beyond the warehouse. So the warehouse continues to be the most important and more diverse use case at Facebook. We have thousands of employees using it every single day. Some people use it directly by writing SQL queries. Other people interact with it through dashboards, reports, or some other tools that hit the Presto clusters. So we run millions of queries every month, and every day we scan trillions of rows, and in the order of 10 or more petabytes per day. I mean, last time I checked, it was around 10. It's probably higher. We have a pretty steep growth curve there. And our warehouse at Facebook is partitioned across geographic regions. So data is physically located across different regions. They are distinct data sets. And we run one Presto cluster for each of those Hadoop, Hive Hadoop installations. And if you look at any one of those Presto clusters at a given point in time, we're running tens of queries concurrently. So last year, we started looking at expanding beyond interactive use for Presto. And the idea is to start taking more and more of the workload that people normally do against Hive, right? They write batch pipelines against Hive. And this all crystallized like sometime end of last year. We worked on a project where there was a product that was running, they had the reporting backend built on top of Hive. They were running reports every day, like scheduled reports. Each report took, I know, anywhere from 2 to a few more hours to execute. And they were in a really tough spot. They were running, they had a backlog of 2,000 reports or so, and it was growing. And they were already using ridiculous amounts of compute capacity to run them, and we couldn't just throw hardware at the problem. So we decided to see, can we use Presto to address this? And so we migrated everything to Presto, and at the end of the day, we ended up seeing an improvement in CPU efficiency of more than 6x. So we need less than a sixth of the number of machines to do the same amount of work. And latency went down like 4 to 10x. So in 3 weeks, so this graph shows the queue length, report queue length. So in 3 weeks, we burned through the entire queue with Presto, and then the system continued to be able to process the new reports that come every day with plenty of spare capacity, and the cluster basically sitting idle most of the time. So now we have a project to start to move more of the workloads that we run on Hive onto Presto, and this is going to be a long road. We need to add a bunch of features that people use in Hive that we don't have in Presto, and basically be able to scale the clusters to, let's say, an order of magnitude larger. This is something we're going to be focusing on over the next few months and for the foreseeable future. So I mentioned we use Presto for other things other than the Hadoop warehouse. There's one particular set of applications where Presto is sitting basically in the line of fire of users interacting with Facebook. So there's a product that exposes reporting capabilities for advertisers. And when they go to a website, they do a bunch of selections on a web form, they click a button, and that's a Presto query. So the requirements are significantly different from what we have in the internal systems in the warehouse. The system can never be down, like it has to be 24/7 up. Queries need to be very, very fast. Like you click a button on a web page and you expect it to come back in a few seconds. So queries need to run between a few hundred milliseconds to 5 seconds or so at most. And the performance has to be consistent. And for one of the applications, there's additional constraints due to the way the application models data. For example, we need to be able to do 10 to 15-way joins of very selective criteria. So we actually don't end up, the queries don't end up touching a lot of data, but they need to be able to run over data sets that potentially have a lot of data. And so that requires, for example, we can't afford to load all the data in memory before we do a join. We had to do optimizations there. And because of the way those systems maintain the data, they basically keep partial aggregates that they update every few minutes. So that means we have to have the ability to update individual entries at a very granular rate. So basically, this all means that we couldn't use Hive and Hadoop as the backend. That you wouldn't be able to support the availability, the latency requirements, the ability to update individual rows. You can't do that with Hive easily. So we decided to build a custom data store for this purpose. And we use the connector, the pluggable connector interface, and we implemented a data store based on sharded MySQL. So it's basically a bunch of MySQL instances. We have a very good infrastructure for that at Facebook. There's a bunch of MySQL instances. We load the data, we partition across multiple instances, and the connector is able to read data across all those instances and feed it to Presto, so it can run the queries and do aggregations, joins, and so on. So since we launched this a couple years ago, the system has been up 24/7 for the entire period. It has never been down. And we've seen pretty high success rate for individual queries. Like there's a chance that some queries will fail, the client will retry, but that chance is pretty low. And performance is also pretty good. Like most queries take anywhere between 50 milliseconds and a few seconds. So it was a pretty successful project. So we have a number of other applications or systems inside Facebook that have very similar requirements in terms of availability, in terms of the latency they expect, the freshness of the data, but they need to be able to process much larger amounts of data. And for example, and they need more flexibility in terms of what kinds of computations they perform over the data, so they need to be able to access the raw data. They can't do partial aggregates, or they can maintain partial aggregates. So MySQL is not a very good option for the alternative for this, because it's a raw store, so it's not very efficient in terms of storage, and it's also not very fast when you try to scan the data from a MySQL instance. So we decided to build a custom data store. We call it Raptor. It's a columnar data store that runs embedded inside Presto instances, and it keeps data, maintains data on local disk. So that, because it runs, the only system that can access and modify that data is Presto. Presto is effectively the one that maintains the shape of the data. We can afford to do things like maintain consistency when data is loaded. We can organize the data in different ways, or have the system organize the data so that the query engine can exploit the organization. All the maintenance can happen in the background with cooperation with the Presto engine without creating things like, I know, you run a query and some data disappears from underneath you and so on. We're running this in production. We've been running it in a couple of different applications. And we have, I don't know, a system that runs a few hundred machines. We have queries that touch several terabytes of data a single query, and they run in the order of a few seconds. So this is, even though we're running in production, the system, the design and the implementation evolves very quickly. We haven't documented it very well yet. So we actually don't suggest that people use it yet, especially because from version to version, we may break backwards compatibility that will require manual migrations to the metadata and so on. So we don't suggest you use it yet, but stay tuned. It's more going to be more coming up on in the next few months. Hopefully, we'll get to a point where we can people can start using it and be confident they will continue to work well. So with that, Camille is going to continue talking about other companies using Presto.
Hi guys, so I'm Camille, I'm an architect at Teradata, and I'm part of the team that works on Presto, which means we contribute to Presto open source, and we also provide sort of a commercial distribution for people who would like to use it in production and get support. But everything we do is open source. I would like to talk a little bit about other uses of Presto beyond Facebook. When we started about a year ago, or over a year ago, with Presto, there were a number of companies using Presto, but this list is much longer now because people realize the value of Presto. And interactive SQL analytics is big, and it's becoming even bigger. So those are a sample of the names that are using Presto today. Most of them are in production with Presto at significant scale, and you can see the full list on a GitHub wiki page. So let's look at some of the stats of Presto users, right? So one of the oldest users of Presto beyond Facebook is Netflix. They run in the cloud for all these sort of interactive reporting and app-driven queries. They have a ton of data in S3 in a Parquet format. They have 250 nodes of Presto running on EC2, spread across several clusters, and it's hundreds of users using this and thousands of queries a day. So pretty massive scale and concurrency. Twitter is actually a new adopter of Presto. They run this for ad hoc low latency queries, about 200 nodes dedicated to Presto, and all of this is Parquet with some nested data structures. Uber, also one of the new users of Presto. They have 2 clusters, 100 machines total, and a couple of thousand queries a day. And that's on-premise. And then the final one I'd like to share is Finra. Finra is a financial company. They run on EC2 as well. It's 120 nodes, 2 petabytes at this point and growing, and 200 users. And this is actually, Finra is one of the users who's using our distribution of Presto and supported by us in production. So, you may ask, like, why Presto is gaining this adoption and momentum, right? So, I think the fact that there's now a significant number of contributors to the project, including 20 people who work at Teradata and contribute to this open source project, we just accelerated the features we're building, right? So in the past year, beyond Facebook and Teradata and Netflix and a few other users who are actually not just users, they also contributors to the project, we developed a number of features. So there's more DDL and DML support right now. There is a bunch of SQL syntax features as well. Standard SQL data types, decimal, varchar, small int, and so on and so on. Sort of more advanced features in SQL language, such as rollup and cube, grouping sets, intersect, non-equijoins, and uncorrelated subqueries. And as Martin mentioned before, we try to very hard to stay true to ANSI SQL standard, which is really great for just compatibility with a number of tools, and it's also the SQL you probably know from other standard SQL databases. So it's sort of relatively easy to migrate off your SQL database to Presto because of that. So beyond just SQL features, we obviously continue to improve performance. Presto was really fast from the beginning, essentially. That's why it was built, right? But we continue to improve performance for joins and aggregation optimizations. That are obviously the most important things you do with SQL, right? Join, aggregate. There's a growing list of connectors to different platforms. So, you already know Presto works on top of HDFS. It works on top of S3. There are connectors for Cassandra and a bunch of other data stores. In the past year, we have 2 new connectors, which is Redis and MongoDB. That's kind of expanding NoSQL data stores that are now, it's now possible to use SQL against them and analyze data that's sitting inside. So beyond those features, we sort of invested, especially our focus at Teradata was to improve sort of enterprise features, right? Obviously, they're boring, but for people who actually want to run this in production, they care about Kerberos, right? So Presto before didn't have access to Kerberized clusters. Now it does. That's a sort of recent contribution. We also take care of sort of ease of installation, monitoring, and just administrating the cluster. That's really important to make it really solid, so people can run this in production. So we have several tools available. Presto Admin is our own CLI-based tool, pretty powerful. But we also integrate with Ambari and Yarn via Apache Slider. So for people who would like to run Presto on the same nodes as their Hadoop cluster, they can use those integrations as well. Okay, so you got all this stuff working in SQL, it's easier to operate, and it's secure, and so on and so on. But now people would like to actually leverage Presto, not by typing SQL directly, but rather using BI tools, right? So, Presto before didn't have ODBC and JDBC drivers, which was a big showstopper for BI integration. So Teradata actually sponsored building those drivers specifically for Presto, and we made them freely available to anyone in the community. You don't have to pay for support to get those from our website. And based on those drivers, we were able to certify with a bunch of BI tools. So we can now use them against most of the very popular BI tools, just listed here. Tableau, Click, MicroStrategy is coming soon, and Zoom Data Looker, Power BI, information builders, and we expect more BI tools to get certified in the coming months. So you'll basically get every tool working. And what's important to know is that the integration we provide is actually live integration, right? So the moment you click on the dashboard, it will generate SQL that will go to Presto. Presto will query your data source, whether that's HDFS or some other data source, and come back with the result, right? We're not talking about like extracting data, bringing into, say, Tableau, and it's all in memory and it's answering quickly, right? That's not the integration we're talking about. It's a live query push down. So, well, that's all great, right? But we have still some work to do. So we'd like to share some of the things we would like to continue to improve in Presto. So in the short term, beyond Kerberos, we'd like to integrate with LDAP. That's also a very common security interface. We'll push to extend SQL. So we would like to add float, var, and binary data types to basically complete all the standard SQL data type work and be like fully compatible with everything on a SQL space. And then we're just adding more features like exist, except, correlated subqueries would be a big addition, prepared statements, and something that goes beyond SQL, which is lambda expressions. So stay tuned for that. And then on the connector list, we already have contributions from Bloomberg. If there's anyone from Bloomberg here, thank you for that. There's pretty soon we'll have Apache Accumulo connector for Presto. We are in the final stages of the code review process before merging that in. Okay, and then looking into the longer term roadmap, which, well, I mean, that work kind of starts conceptually around summer, in spring this year. We are prototyping some of those things, and now towards the end of the year, and then next year we'll be pushing on several important fronts for Presto. First one is materialized query tables, which is essentially materialized views that are known from other database systems. We'll be sort of enhancing workload management in Presto to allow you to specify, how much CPU or memory you want to use for a specific group of users, so they don't conflict and they know what's the priority of the queries. And then spill to disk. That's something that's important because today Presto basically operates fully in memory, which is great for performance, right? But there are queries that are maybe slightly exceeding your memory. So, today the query will fail. What we would like to do is basically to allow Presto to intelligently spill to disk, but only when it's actually necessary, right? Because spilling to disk kills performance, and we don't want to do that unnecessarily. And then the final big project, which will start this year, it's still sort of in a design prototype phase. Martin is working on this, over the weekends and long nights. It's a cost-based optimizer. So Presto will feature, specifically designed for Presto cost-based optimizer, and I will be happy to talk more about this probably next year in detail. And because we do everything in the open, you can go to our GitHub wiki page and see the progress on the roadmap items and track improvements. And if you would like to continue to use Presto and then submit feature requests and ideas or contribute some code, you're more than welcome to do so. So this is just a few links for more information about Presto. Obviously everything happens on GitHub, so those are the two URLs for checking out the latest developments in the community. There's the website, there's Presto users group, which is pretty active. People are submitting questions and issues and get answers. And then, if you would like to try Presto easily through, trying as a sandbox VM or easy to install package bundled with all the tools together and the drivers and everything, just go to teradata.com/Presto. And that is free to everyone to use. And if you would like to run it in production, give us a call. We'll talk to you more. All right, thanks so much. We're open for questions. So someone in the mic, or just go ahead, speak.
I'm not sure if this is a minority question or a situation, but I used to use Presto for like 2 years, and then I gave up because I'm a solo guy doing Hadoop admin, data wrangling, machine learning, and deploying stuff to production.
Okay.
So I chose Cloudera because they have a great manager and everything. No offense.
Yep.
But I think